Today, we're going to talk about a new frontier in robotics. And I mean a frontier that's moving way beyond the factory floor and into our homes, into our lives, and get this, even inside our own bodies. So, I want you to forget what you think you know about robots. The future is about to get very, very personal.
So let me ask you a question. When I say the word robot, what's the first image that pops into your head? For a lot of us, it's probably something straight out of the movies, right? C-3PO, maybe the Terminator if you're feeling a little dramatic. But the reality of where this tech is actually going, it is so radically different, and it's being shaped right now by some incredible research at places like Stanford University.
We imagine these rigid metallic humanoids walking around, but the real frontiers are somewhere else entirely. We're talking about super dexterous helpers, soft robots inspired by nature, intelligent prosthetics that augment our bodies, and, this is the wild one, robots that are literally designed to work inside us. Okay, so let's start with the world we can actually see and touch. How are robots being designed to interact with us, in our everyday lives?
Well, according to Professor Monroe Kennedy at Stanford, the whole push for these robots isn't just about building cool tech. It's really about solving fundamental human problems. Think about it. Assisting an aging population so they can stay independent in their homes longer, or bringing complex manufacturing back to our own communities. This is about real-world needs, not just some sci-fi novelty. But here's the catch. For a robot to be truly useful in your house, to say, load the dishwasher or sort your laundry or even pick a piece of fruit, it needs to do way more than just see. It needs to feel. As Professor Kennedy puts it so perfectly, the biggest barrier is a sense of human touch. And here's a great way to think about it. There was an experiment that showed if your finger is numb, it takes you 3 to 4 times longer to strike a match. Even if you can see it perfectly, your vision just isn't enough for these really delicate tasks. You need that physical feedback. And that is the exact numb finger problem that robots have been facing for years. So, the solution is a technology called tactile sensing. This is the magic that gives a robot that sense of touch. It lets it understand things like pressure and texture and shape. Really, all the things our own fingertips tell us without us even thinking about it. So how on earth do you teach a robot to feel? Well, the solution is it's brilliant. Researchers embed a tiny camera inside a soft, gel-like robot fingertip. Then, the robot just watches a human do a task. As it watches, an AI starts to find patterns, connecting how the gel squishes and deforms to the amount of force being used. And through that process, it actually learns how to handle something as delicate as a strawberry without crushing it. How cool is that? But as incredible as giving robots a sense of touch is, the next frontier, well, it requires an even more delicate approach. The scale is about to shrink dramatically as we move from robots in our world to robots inside of us. And this brings us to the work of another incredible researcher, Professor Renee Xiao. Her lab is developing soft, tiny, miniaturized robots designed for, well, the most delicate environment you can possibly imagine, the human body. And look, the stakes here could not be higher. 1/3 of all global deaths, 1/3, are caused by diseases of the circulatory system, and a huge chunk of those, more than 1/4, are from illnesses caused by blood clots, like a stroke. So solving this isn't science fiction. This is literally a matter of life and death. So how do you even begin to build a robot that can navigate our incredibly complex network of blood vessels? Well, you look to nature. Professor Xiao's lab gets its inspiration from soft-bodied organisms that can move in these incredible ways without a single bone. Think about an earthworm crawling, or an octopus arm, or an elephant's trunk. This whole approach just completely rethinks what a robot even is. So instead of bulky motors and gears, these soft robots are driven by the deformation of their own material. This gives them amazing flexibility, what engineers call near infinite degrees of freedom. They can be made super small, and, this is crucial, they can be controlled by external forces, like magnetic fields. So no need for internal batteries or wires. And this new approach has enabled a totally different way to treat blood clots. The team has developed this tiny robotic spinner that doesn't just try to pull the clot out. By spinning really fast inside the clot, it actually breaks it down from within. Professor Xiao has this great way of describing it. She says it eats the clot. This spinning motion tightens up the clot's fibrous network and basically squeezes out all the trapped blood cells. The result is it's incredible. We're talking about a 95% reduction in the clot's volume.
That makes it small enough to be easily removed, and it could completely change the game for treating strokes.
Okay, and this is where our two stories from these two different labs come together to create what could be the future of surgery. You see, treating a stroke right now is unbelievably difficult. The catheters they use are often way too rigid to navigate the super twisty, tiny blood vessels in the brain. It takes surgeons more than a decade of hyper-specialized training, and there just aren't many of these experts to go around. In the end, a patient's survival can literally come down to the individual skill and steady hand of just one person. But this new system they're building together, it changes everything. A surgeon inserts the tiny magnetic robot. Then an external robotic arm uses magnetic fields to guide it precisely through the brain, right to the clot. The little robot does its work, eats the clot, and is guided back out. It's elegant, it's precise, and it could be accessible to so many more people. It's really a perfect partnership. You've got Professor Xiao's lab designing the tiny soft robot that actually works inside the body, and then you have Professor Kennedy's lab developing the brilliant AI and control system for the big external arm that guides it. Together, they're turning what was once a complex manual art form into a repeatable automated procedure. So, what does all of this mean for our future? I mean, where is this technology really heading? Think about the journey we just went on. We went from a robot that can gently hold a strawberry to one that can navigate the arteries of the human brain. And they might seem like they're worlds apart, right? But they share this common thread, this common goal: solving deeply human problems. From our basic desire for independence to our fundamental need for life-saving medicine. And all of this leaves us with a really fascinating final question to think about. As these technologies become an extension of our own abilities, and in some cases literally a part of us, where do we draw the line? At what point does a tool stop being just a tool and become a true partner in our lives?